Now let's go back to our code. Now to create a custom policy and assign it to your Lambda function, we need to create another resource. So here I will add another resource called custom role. Now the type will be AWS IAM role, because we're creating an IAM role here. And then, like all the types, it will have some properties. I don't want to do a lot of typing here, so I'm just going to copy few attributes under properties section. So the first thing we need here is the path. And then we need to name our role. Now I'm just going to name my role as mycust role dash and then the environment that we are in. And then I'm going to add assume role policy document. Now this part just tells us like we are assuming an STS role. STS is a temporary token that AWS will provide to your Lambda function or to this role. And in this case, it's a Lambda service, so AWS will provide a temporary token to assume this whole role that we are creating to this service, which is Lambda, and effect is allowed. So whatever roles and actions we will list down in a moment will be allowed by this role for this Lambda function to perform. Now the next part I'm going to add is the actual policy that will provide certain permissions to this Lambda function via this STS temporary token. This needs to go here, and policy will be under assume policy, and policy will be under assume role policy document. Right. The next attribute and the properties is policies. What policies we want to attach to this role policy document. Now the first one I'm adding here is the custom role policy, and then the policy document which has a version, and then the actual statement. So here I'm allowing my Lambda function to be able to create a log group, create log stream, and then write the logs. So these are different actions that this Lambda function will be allowed to perform on CloudWatch. So these are just the actions. Your statement will also have the resource that will be allowed to perform these actions. So I'm going to just add the resource, and I'm just adding all the Lambda functions under this account, current account, and in this region to be able to perform these actions. Similarly, I want to provide access to our DynamoDB table. Now this is a list, the statement attribute, so I can add another action here. Just make sure your indentation is correct. This is a YAML file. Alright, so the second one we added is to allow action on DynamoDB. Now we could have put individual actions here, like put item, delete item stuff. I'm just going to whitelist all the actions on DynamoDB. And then I've added the DynamoDB table. So here I'm adding our DynamoDB table. This is the ARN for our table, right? I'm just giving the path to the whole ARN, and in the end I'm using the reference to our users table which we just created here, right? So under this policy, right, so this needs to go back one step. Yeah, so now this is our custom policy, right? We added a assume policy document and then the actual policies, right? And under the actual policy we had individual action permissions that we want on different resources and the list of actions that they can perform. Now we can add this custom role that we have created to our function here. So I will add the custom role, the same name that we created here. Just save it. Let's go back to our deployment, CLI, and run it again. Oh, it has failed. It seems like I already have a role created with the same name. So I'm going to go back to Visual Studio Code. So here I'm going to modify my role name. I'm just going to put 1 here, or maybe just change it to DynamoDB Lambda and then the stage. Let's add the name as well. And then also change, let's rename the policy name as well to DynamoDB Lambda role. And let's change the custom role name here as well, just in case it conflicts. As well. Looks good. Alright, let's go back and then retry the deployment. So our deployment is complete here. We have a new role assigned to our Lambda function, which gives access to our Lambda function to perform all the operations on DynamoDB table. Now let's go back to our Postman and try our API endpoint once again. And this time we got a 200 OK response. Now let's go to our AWS console. Go to our tables. Let's go to our tables and then to our users table. Now to explore items, we have to go to explore items section, and here you will see that our user is saved successfully. All our data that we sent through post call is added. We have the updated at and created at timestamp added as well. Now what we want to do here is encrypt our password, right? So if you remember, in DynamoDB we want to encrypt the password that we will receive here under item using our bcrypt.js module. Now to encrypt our password, all I need to do is after we are spreading the item, I need to add the password attribute and override the password with encrypted password. So I'm just going to use the bcrypt hash sync function, which takes in the password and also take salt. Let's save it and redeploy our code. So our code is deployed. Let's go to Postman and let's retry our API endpoint. We got a 200 OK response. Let's go to our console. Now if I refresh, my password is updated with the encrypted password, right? So we are using a DynamoDB put function. So this will always override my item if I'm trying to save it again. Because in our user table we set a primary key as email. So if we try to save another item in our DynamoDB with the same email ID, which is our primary key here, it will get overwritten. So we are able to create our user and save it successfully in DynamoDB. That's all for this lecture. In the next lectures, we will create more Lambda functions and we'll see how we can update this user, fetch users, and then delete them. Thank you, and I'll see you in the next one.